Hello students, today we are going to study about a very important topic in your chemistry, which is called as a bond angle. So let's define the bond angle first. What is the meaning of the bond angle? So the definition is bond angle is the angle between two bonds. As we know that whenever there is a formation of a molecule, they are formed by the bonds between the atoms. So the angle between the bonds is called as bond angle. For example, suppose we have a BF3 molecule called as boron trifluoride. So we have this fluorine boron fluorine bond. Two BF bonds are there. The angle between them is 120 degree. Now this is called as a bond angle. So students, in your entrance exam, there will be a very important topic where they will give you different molecules and they will ask you to arrange them in the increasing order or the decreasing order of the bond angle. So let's see how to determine the bond angle in the molecule and their increasing and decreasing order. Okay, now there are different cases. Let's take case number 1. The case number 1 is when there is no lone pair present in a molecule, and we can directly using the formula by using the hybridization we can determine the order of the bond angle. So we will use hybridization. So according to hybridization, if there is sp hybridization, bond angle is 180 degree. We have a linear molecule, so bond angle becomes 180 degree. In case of sp2, the bond angle is 120 degree. We have a trigonal planar geometry, bond angle becomes 120. In case of sp3, the bond angle becomes 109 degree 28 minutes. The geometry becomes tetrahedral. In case of sp3d, now in sp3d we have two different types of bond angle. It is a axial plane and equatorial plane. In equatorial plane, the bond angle is 120 degree. As you are seeing, the three bonds, they are arranged by 120 degree angle. And then we have two axial bonds, mutually 90 degree above and below the plane. So the axial bonds are comparatively weak bond. This is a geometry that we will get for sp3d hybridization, diagonal bipyramidal geometry. So the bond angle over here, if you observe, we have two different types of bond angle, 120 degree as well as 90 degree. In case of sp3d2, the bond angle in sp3d2 is 90 degree. In case of sp3d3 hybridization, in sp3d3 hybridization we have the geometry like pentagonal bipyramidal, just like this. In center we have a pentagon, and then above and below the plane we have 90 degree. So as 360 degrees divided between the 5 different bonds, each angle we will calculate, it will become how much? 72 degree. and 90-degree axial bonds. So students, as you observe, by using the hybridization, we can compare the geometry of the molecule. Now, in your entrance exam, we can compare the bond angle by using the hybridization. Sp is always greater than sp2 and sp2 is greater than sp3. So suppose in the exam they give you the molecule where the molecules have different hybridization. So you can easily calculate the bond angle and their increasing and decreasing order. Let's take one example. For example, I have methane molecule, BF3 molecule and BeCl2 molecule. So as you observe, methane molecule is sp3 hybridized, BF3 molecule is sp2 hybridized and BeCl2 molecule is sp hybridized. So students, what will be the order of bond angle? Obviously sp is greater than sp2 and sp2 is greater than sp, so our bond angle order will be like this: methane, BF3, BeCl2. The highest one is BeCl2 and the lowest one is methane molecule. This is our case number 1. So we compared the bond angle in case number 1 where there is no lone pair present by using the phenomenon of hybridization. Okay students, now let's move on to the case number 2. Case number 2 where there is a lone pair present on the central atom. So how to find the hybridization? Case 2, in the presence of lone pair. So if there is a presence of lone pair, the rule says greater the number of lone pairs, greater the number of lone pair electrons, smaller is the bond angle. Understood? That means as the lone pair electron on central atom increases, the bond angle actually decreases. Let's see one example. For example, suppose I have methane, ammonia and water molecule. Now if you observe, in case of methane, we have sp3 hybridization. In case of ammonia also we have sp3 hybridization, and in case of water also we have sp3 hybridization. So here we are taking the case 2 where there is a presence of lone pair but the molecules have same hybridization. Different hybridization, so we had already done. sp3 is smaller than sp2 and sp2 is smaller than sp. Now if all the molecules have same hybridization, then how we will compare the bond angle? So there comes the presence of lone pair. Now if you see ammonia molecule, in ammonia there is one lone pair present on nitrogen atom. In water there are two lone pair present on oxygen atom. In methane the central atom carbon has no lone pair. So in this case, as the number of lone pair increases, the bond angle gradually decreases like this. So if you see the bond angle, in case of methane it is 109 degree 28 minutes. In case of ammonia it becomes 107 degree 18 minutes. and in case of water it becomes 104 degree 28 minutes. So gradually the bond angle decreases as the lone pair increases. So in this way we had done the two different cases. Okay, case 1 by using the hybridization, and case 2 where the molecule has same hybridization but we then arrange the order by using the lone pair electron. Now we'll go to the another case. Case number 3. What will happen if the molecule have same hybridization and same lone pair? Now the molecule has hybridization also equal and they have same number of lone pair electron. Students, in this case we have two different conditions. Let's see what. The two different condition becomes either the molecules will have same central atom and different side atoms. This is your case number 1. If the molecule have same hybridization, same lone pair, then either they will have same central atom and different side atom, or they will have same side atom and different central atom. So in these two scenarios we will see how to determine the bond angle. Case A and case B. Case A, same central atom and different side atom, and case 2, same side atom but different central atom. So let's go to our first case number 1. The molecule having same hybridization and same lone pair, but they will have same central atom and different side atom. So let's go to our case A. Same central atom, different side atoms, and there is same hybridization and also they have same lone pair. Students, in this case where we have same hybridization and same lone pair, we have to use electronegativity. The rule says greater the electronegativity of side atom, smaller will be the bond angle. Greater the electronegativity of side atom, smaller will be the bond angle. So let's see this by using the example. For example, I have the molecule BeF2, BeCl2 and BeBr2, and I want to arrange them in the decreasing order of bond angle. So let's find out how to go about it. If you see the hybridization in BeF2, in BeCl2 and in BeBr2, they all are sp hybridized. They all are sp hybridized and they all have no lone pair electron, 0 lone pair electron, and they all are sp hybridized. So that means they have same hybridization and they have same number of lone pair. So how to arrange the bond angle then? So you have to see the side atom because they all have same central atom. See, their all central atom is beryllium. So observe the side atom. Side atom is the halogens fluorine, chlorine and bromine. And in the periodic table we know that as we move down the group, from fluorine, chlorine and bromine, what will happen, the students? Electronegativity decreases. And what our rule suggests? Greater the electronegativity of side atom, smaller is the bond angle. So smaller the electronegativity, greater will be the bond angle. So as we move from top to bottom, fluorine, chlorine, bromine, your electronegativity decreases. So obviously the bond angle increases. So students, what will be the order? If I put the increasing order, what will happen? The highest bond order will be of bromine, because electronegativity of bromine is least. So the bond angle will be highest for bromine. So our correct order will be BeF2, BeCl2, and the highest one will be what? BeBr2. So this is our case A, where we have the molecule having same hybridization and same lone pair electron, but they have same central atom and different side atoms. So we had arranged the bond angle by using the electronegativity. What the rule says? Greater the electronegativity of side atom, smaller will be the bond angle. Now we'll move to the case number 2. What the second case says? Second case says that we have same side atom but different central atom. Okay, so here also we have same hybridization, other conditions are same hybridization, and we have same number of lone pair. This condition remains same. We have same central atom, same side atom but different central atom. So what will happen over here? In this case, because we have different central atom and same side atom, so the rule says greater the electronegativity of your central atom, more will be the bond angle. ठीक है, तो सेंट्रल एटम की इलेक्ट्रोनेगेटिविटी बढ़ाते जाएंगे तो बॉन्ड एंगल की वैल्यू भी बढ़ती जाएगी. दिस इज द रूल ओवर हियर. तो यहाँ पर इफ़ यू ऑब्जर्व, लेट्स टेक वन एग्जाम्पल. ठीक है, द एग्जाम्पल इज सपोज आई हैव NH3, PH3, ASH3 और SbH3. ठीक है, suppose we have these 4 angles. Now as you know, in the periodic table, nitrogen, phosphorus, arsenic, antimony, as we move from top to bottom, what happens? Nitrogen, phosphorus, arsenic, antimony, the electronegativity decreases. And because electronegativity decreases, what will happen to bond angle? The bond angle also decreases. This is the rule. Greater the electronegativity, more will be the bond angle, guys. So as you move top to bottom, electronegativity decreases, bond angle also decreases. So here my order will become what? Because you know nitrogen is most electronegative, so bond angle of ammonia will be greater than PH3, and then it will be greater than ASH3, and the highest will be SbH3. Okay, so I hope now you are clear how to arrange the bond angle in your entrance exams. These are the 3 main cases. One where we have no lone pair electron, second where we have same hybridization but different lone pair, and third where we have same hybridization and same lone pair. So all the three cases we had covered. I hope you will be able to solve all your problems in entrance exam based on the bond angle. Thank you guys.